Right, these are the notes over conditional statements, dealing with conditional statements, and then we're going to cover a couple of laws. First statement. When you read a statement, you got to take it to that it's the rule. Nothing else. You can't read anything else into it. You got to take it that that is the rule. So this rule says if you drive over 65, so we know if you're going over 65, you will receive a ticket. No matter what you actually see out in the real world, when we're dealing with something in here, thinking logically, you got to take this as the set rule. And we're going to try to decide whether each of these next statements are true, false, whatever. You drive 70 miles an hour, you receive a ticket. According to our rule up here, you're going over 65, so you're going to get a ticket. So that's a true statement. Next one, you drive 63 miles an hour and you don't receive a ticket. Now here's where you got to be careful, something like this one. Our rule up here stated that if you drive over 65 miles per hour, so that's all we know about. We don't know about anything else other than if you drive over 65 miles per hour. So if you're driving 63 miles per hour, you may get a ticket, you may not. So on this one, your answer should be no conclusion can be drawn. We can't decide because our rule up here, our original statement, did not tell us what's going to happen if we drive under 65 miles per hour. It only told us if we drive over 65. Last one, you drive 72 miles an hour and you don't receive a ticket. Well, our rule tells us if you drive over 65, which 72 is over 65, you're going to get a ticket. So, according to this, according to our rule, that statement is false. All right, conditional statements, and I'm going to write these up real quick. Conditional statement, our hypothesis, making color here. Our hypothesis, if it is Saturday, so that's your hypothesis. The conclusion, we don't have school. That's your conclusion. The converse, remember the converse just switches the order of the hypothesis and the conclusion. So if we don't have school, then it is Saturday. As you're doing each one of these, and I should have done it with the original conditional statement, you got to decide whether it's truth, decide its truth value. the original one, if it is Saturday here at National Trail, if it's Saturday, then we don't have school. That's a true statement. The converse, we don't have school, so we know we don't have school that day. Does that tell us for sure it's Saturday? No, so that's a false statement. The inverse. The inverse leaves the original statement in the same order, but negates both parts. So it leaves it in the same order, but negates both parts. So our inverse is going to say, if it is not Saturday, then we don't have school. Or I'm sorry, not we don't. We negate both parts. We have school. So it's not Saturday. We have school every day. Again, that's a false statement. And for any time you give a statement that's false, you should be able to give a counter example. So if I look back up here, we don't have school. So it's a day that we don't have school. Can we say it's Saturday? No. Counter example. Counter example, an example that shows that that statement's not always true, is it could be Sunday. We don't have school on Sundays either. Counter example for this one, for the inverse, could be the same thing. Contrapositive. Contrapositive takes the original statement, switches the order, and negates both parts. So the contrapositive would say if we switch the order, then we negate both parts. So if we have school, then it is not Saturday. Now, the contrapositive is sort of hard to decide whether it's true or false. So to decide the truth value of it, the contrapositive is sort of difficult. Again, I told you with the contrapositive, if the original statement is true, then quite often the contrapositive will also be true. In this case, if we think about it, we're at school. Is it going to be Saturday if we're sitting here at school? No. So this is a true statement, because we know it's not Saturday. Next one, conditional statement. If two angles form a linear pair, so you got two angles here, that's your hypothesis. They form a linear pair, then they are supplementary. That's your conclusion. Converse, you're going to switch it around. Now it's got to make sense when you switch it around. So you can't just say if they are supplementary, then two angles form a linear pair. It's got to make sense. So that subject, the two angles, we're going to leave it in the first part. If two angles if two angles are supplementary, then they form a linear pair. Remember, a linear pair have two angles that together form a line. Those two angles, angles 1 and 2, are a linear pair. Well, they're also supplementary. The original conditional statement was a true statement. If two angles form a linear pair, then they're supplementary. The converse, if two angles are supplementary, then they form a linear pair. Well, that's false. And the reason it's false, you could give a counterexample. If I drew that angle and told you it was 70 degrees, I drew this angle and told you it was 110. Those two angles are supplementary, but together they don't form a line. So that would be a counterexample. The inverse. The inverse leaves it in the same, leaves the original statement in the same order, but negates both parts. So the inverse would be if two angles do not form a linear pair, then they are not supplementary. Counterexample for this, we could use that same counterexample. These two angles don't form a linear pair, the 70 degree and the 110. They don't form a linear pair because together they don't form a line, but they are still supplementary. So that tells us that this statement is false, and we could use that as a counterexample. Contrapositive switches the order and negates both parts. So it switches the order and negates both parts. So it's going to say, if two angles are supplementary, then they form if two angles are not supplementary, got a word in there, then they do not form a linear pair. Now, to decide whether that's true or false, think about, you've got two angles, they're not supplementary to each other, so you might have a 20-degree angle and a 50-degree angle. Well, can those two form a linear pair? No, so this is a true statement, because if two angles aren't supplementary to each other, then there's no possible way they can form a linear pair. All right, page 78, problem 14, we're going to look at that. The main thing with problem 14 is to look at it and to be able to write it as an if and then statement. Then you can do all the other stuff with it. But you have to write it as an if and then statement first. And sometimes grammatically, that's sort of hard to do. All right, what we're going to cover today, two laws dealing with deductive reasoning. Deductive reasoning, we talked about inductive reasoning, that's using patterns and things you've seen in the past. Deductive reasoning is using laws, rules, any kind of mathematical rule to think something through to come up with a conclusion. And the two main laws that we're going to cover today, law of detachment, law of syllogism. Again, deductive reasoning, thinking something through, going through and coming up with a conclusion based on some kind of rules. Law of detachment, or detachment, take apart, and that's sort of what this is. The law of detachment says if P tells you Q, so if P goes to Q, or P tells you to Q, and we know that that's true, and P is true all by itself, so if we take the P out and it's true all by itself, then the Q statement must also be true all by itself. So that's all you're doing is taking it apart. So if we know that P goes to Q is true, and then we know P all alone is true, then the second part has to be true all by itself also. So something like John is 20 and Joe is 35. If we know that that's a true statement, and then we know, so that whole thing together is true, and then we know that John is 20 is true, then we know Joe has to be 35. So you can just split up the statement, and that's what the law of detachment is. The law of syllogism. Law of syllogism is sort of like this rule in algebra. In algebra, you had this rule: A equals B, and B equals C. Then from that, you could decide that A had to equal C. And that's sort of the same thing as the law of syllogism. Law of syllogism says, if P tells you Q, so P goes to Q, and then Q goes to R, and it has to go in that order, where Q comes second in the first statement, and then that Q comes first in the second statement. Well, if P goes to Q and Q goes to R, then we can say that P goes to R must be true. So something we could make up, just something silly. If Fred, then Joe, and if we know that that's true, and then we say if Joe, then Sally, and we know those two are true, so we know both those are true, then we can come up with the conclusion that if Fred, then Sally, and we can say for sure that that's true. That's the law of syllogism. All right, if two segments have equal length, then they're congruent. So we have this statement, two segments have equal lengths, then we know that they are congruent. So that's what we said about congruent earlier in the year. So we're given that AB equals 8, CD equals 8. Well, from that, from this original statement, and then from this statement where AB is 8, CD is 8, what conclusion can we draw? We can draw that segment AB is congruent to segment CD. Two angles are vertical, then they're congruent. So we have this. Well, if we know that two angles are vertical, using the law of detachment, we also know that they can be congruent. So you got to be careful here. Angle ABC is congruent to angle DEF. So now we know that these two angles are congruent. Does that tell us for sure that those two angles are vertical? And a counterexample I could draw here could say that that angle's 50 degrees. This angle's 50 degrees. Well, just because they're both 50 degrees and they're both congruent, does that necessarily mean that they're vertical? No, so on this one, you can't come up with a conclusion, so you just write no conclusion. It goes in the wrong order. You can't just turn it around and say, all right, we have congruent things, starting with this second part, we have congruent things, therefore we know that they're vertical. It doesn't work backwards. Law of syllogism. If you eat Cheerios, then you will have a healthy heart. So that's our first statement. We're going to take it for granted that that's true because that's what they're telling us. Second statement, if you have a healthy heart, then you will live longer. Again, we're going to take that to be true. We want to come up with a conclusion. Well, using this, got you eat Cheerios. That's like our first thing. You eat Cheerios, you will have a healthy heart. Well, that healthy heart leads us right to, then you will live longer. So our conclusion that we can draw, if you eat Cheerios, then you will live longer. And we can use the law of syllogism because eating Cheerios led us to a healthy heart led us to living longer. So eating Cheerios could directly lead us to living longer. All right, on this practice, page 84, problems 4 through 9. Try them. I'll walk around and help you as you're trying them, and then we'll probably go over them. The assignment's on page 78. That was part of the assignment last time too, was on page 78. There's some new problems off 78 and page 85.